Hey math kids, today we're going to talk about trigonometric equations, and this is the problem that we're going to start with. And what they're asking us to do is they want us to solve it using radians and the graph. And so all we need to do is go to Desmos or use our graphing calculator, and we're going to graph cosine x. And then we're also going to graph 0.04 is equal, no, it's 0.4. 0.4 is equal to y. And we're looking at it from 0 to 10. And so we see that we just want those x values, those 4 x values right there. So everywhere that this line crosses in between 0 and 10, or I guess there's only 3, 1, 2, 3, until we get to 10, yeah. And so we get 7.442, 5.124, and 1.159. Now, of course, we'd want to round those to 3 significant figures. And so this one would be 1.16, this one would be 5.12, this one would be 7.44. Okay, so that's all we needed to do on that one. Okay, and let's see what else in this section. Now we have 2 sine x minus cosine x equals 4 minus x. We want to go from 0 to 2 pi. Okay. Now the process is going to be the same, however, I'm going to show you how to do it on a handheld graphing calculator instead of Desmos, because unfortunately you can't use Desmos on the IB test. So we just do 2 sine x minus cosine x you want to make sure that your calculator is in radians. Mine defaults to radians, so I just graph these two separately. So I graph this side of the equation, and then on the next one I graph this one. If you want to change it to radians, you go to mode and then go down and then select degrees right here. Okay, so I go back to this. Now I want to graph it. There's my sine and cosine mixture function. And then there's that. Okay, so just like roughly eyeballing it, it looks like there's 3 intersection points. And we want to look from 0 to 2 pi. And so if we want to change our window, just to make it a little bit easier, I'm going to go from 0 to 7 on the x-axis, because 2 pi is close to 6. And I want to give myself a little bit of room to look. And then the y-axis, maybe I'll just keep that the same. Let's see how this one looks. Okay. That's still kind of hard to see. So I'm going to get rid of about half of that. So I'm going to go back to the window. I'm going to go to -5 and 5 on the y and see if that helps me a little bit. This will probably be good enough, even if it is kind of hard to see. Alright, that's definitely better. Okay, so 6 is right here, so we're definitely within 2 pi on all of these. So from 0 to 2 pi. Okay, because that was given in the problem. Now we want to go second, calc, and we want to find an intersection. And if you only have 2 curves on the screen, you can just go click, click, and then we want to guess. So I'm going to guess the farthest left one first. So you just want to click where you think they're intersecting. And what did we get for the x value? 1.82. Let's see. I did not put it out. Go through that process again. Second, calc, go down to intersect, click twice because we only have 2 curves on the screen, and guess. 3.78 if we round that. Okay, and then the last one, second, calc, intersect. Oh wait, first curve, second curve, and then wherever they intersect is about there. And we get 5.81. Okay, those are the 3 x values that make that true. So instead of going through a ton of algebra, we can just do that. Okay, now we need to solve for x on the domain from 0. This is a new problem. So once again, we're in between 0 and 2 pi. And we want to do cosine x is equal to negative square root of 3 halves. We also want to do 2 sine x minus 1. We also want to do, I think we're going to focus on those two, and then I'll do the, just because I don't have room. Actually, let's just erase this. Make that bigger. Okay, and then the last one on this part is tangent x plus the square root of 3 equals 0. Okay, now we're not going to use a calculator for these ones. Oh, I didn't even finish this one. This one is equal to 0. So we're not going to use a calculator on these ones. We're going to use the unit circle instead. So what we're going to do on this first one, draw our unit circle, and we have negative square root of 3 over 2. Now what we want to do is look at our tick marks that we have memorized, hopefully, and this is square root of 3 over 2 comma 1/2. Okay, so that's what we want an x value that's kind of like this, right? Now if we reflect that across, we get something like that. This is negative square root of 3 halves 1/2. And then if we reflect it across here, we're going to have that same x value. So negative square root of 3 halves, negative 1/2. Okay. So when you're doing that, we know that this angle is, so in the original, this is pi 6th, right? So we know that that's also pi 6th. And we also know that that's pi 6th. So each of those green angles are pi 6th. So what we're going to do, we know this is pi. And so if we do pi minus pi 6th, we'll get here. And if we do pi plus pi 6th, we'll get here. Okay? So we have pi minus pi 6th. Then we have pi plus pi 6th. So we think of that pi as 6 over 6 in both of these cases. So that's going to give us 5 pi 6th. And this one's going to give us 7 pi 6th. And so if we plug in cosine of 5 pi 6 or cosine of 7 pi 6, we will get negative square root of 3 over 2. And remember, we're going from 0 to 2 pi, so that's just one full rotation, so we don't have to rotate anymore to get that to work. Okay, now this one we want to solve for sine x first, so I'm going to add 1. And then divide by 2. And so now we're looking for a sine value of 1/2. Once again, it's only one rotation. And so we're looking for a y value that meets that criteria. So we look at our first 3 tick marks. And we see from this problem that it is the same tick mark. Okay, so now the only difference is, so we're going to reflect over here, but since it's a positive y value, it's going to be those 2 points. And so the first one is kind of given to us, right? Because we know what this is. It's just pi 6. So the first answer for this one is pi over 6. Now, we know if we draw a tick mark here, we know that that's pi 6, and so if we do pi minus pi 6, we're going to get 5 pi 6, because we already did the math right there. But you could go through it again. Pi minus pi 6. This is 6 over 6. 6 minus 1 gives us 5 pi 6. The 2 answers are pi 6 and 5 pi 6 that make that true. Alright, I'll just move this over a little bit. Okay, so for tangent, we want to solve for tangent. You always want to solve for the trig function when we're doing this. So tangent x equals negative square root of 3. Okay, so our possible, we have 1/2 and square root of 3 halves, right? And we want the one that gives us it's y over x. So we're looking for this one, because if we went square root of 3 halves divided by 1/2, that's going to flip upside down, and the 2's would cancel. Okay. Now specifically, we need one that has either a negative here or a negative here. We want them to have opposite signs. So if this one's negative, this one's positive. This one's negative, this one's positive. Okay. So we go to our unit circle, and first we want to find this point. So that's actually our 3rd tick mark, because this one is 1/2 square root of 3 halves. Okay, if we're symmetric right there, then we're going to get negative 1/2 comma square root of 3 halves. Okay. Then if we're symmetric here, we're going to get both negative. And then if we're symmetric here, we're going to get 1/2 comma negative 3 halves. So the 2 that we want, let's see, I'll mark them in white. So we're going here and here. Once again, we want them to have opposite signs, because this is negative, and we need it to be 1/2 and then square root of 3 halves. So it needs to be in that order. So we just need to figure out what the angles are. Now, from here to here is pi half, or pi 6. And right here is the first tick mark, right here is the first tick mark as well. And so those are pi 6. So this is pi halves. And so we can go from pi halves plus pi 6. And then right here, we have 3 pi halves plus pi 6. All right, now we just need to simplify. So this is 3 over 3. This is also 3 over 3 to get the same denominator. So we get 3 pi plus pi, and they're both over 6. And this one we get 9 pi over 6 plus pi over 6. So we get 3 plus 1, so we get 4 pi sixths, which is 2 pi thirds. So that's our first answer, and then this is 10 pi sixths, which is 5 pi thirds. Okay, so those are the two values that we could plug in for x that would give us negative square root of 3. All right, we're just going to keep going. It's going to be a long video. Okay, so now we have cosine squared x equals 1/2. We're going from 0 to 2 pi. Okay, so what we need to do first is solve for cosine, just like the other ones. So we're going to square root both sides. And so we get cosine x equals plus or minus 1 over square root of 2. So if we square root the top, square root the bottom, we get that. Now, we didn't like memorize it in that form, but if we do square root of 2 over square root of 2, we're going to see that we get plus or minus square root of 2 over 2. Okay, and now that lines up with how we memorized the unit circle. Okay, so this is what we're looking for. And if we do a unit circle, it's our second tick mark, the one right in the middle. So we have these ones, right? This is square root of 2 over 2, comma, square root of 2 over 2. And we're focusing on the x values, right? So if we go over here, we get the same thing. The x would be negative in that case. Go down here, square root of 2 over 2, square root of 2 over 2. This time they're both negative. And then we go over here, we get square root of 2 over 2, square root of 2 over 2. This time just the y is negative. Okay, so we have 4 solutions to this. And then we just need to find all of those angles. The first one's given to us because we know that that's pi fourths. And so that's one of our answers. Now this one we can approach it 2 different ways. We can say pi halves plus pi fourths, or we can say pi minus pi fourths. It doesn't actually matter. So I'm going to just say pi minus pi fourths. And this would be 4 over 4. And so 4 minus 1 would be 3 pi fourths. So this one is 3 pi fourths. Once again, that represents the angle rotating from here to here. Okay, this one is going to be pi plus pi fourths. So if I just put a plus sign right here, it's going to be 5 pi fourths. So that's just pi plus pi fourths. 5 pi fourths. And then I'm going to do 2 pi minus pi fourths. 2 pi minus pi fourths. Okay, times this by 4 over 4. So that's going to be 8 pi minus pi, and they're both over 4. And so it's going to be 7 pi fourths, which is this one right here, 7 pi fourths. And just to be clear, 7 pi fourths is the rotation from here all the way to this line. Okay, let's keep going. Okay, now we're going to go from 0 to 3 pi. So that's 1.5 rotations. Okay, and we got sine x is equal to -1/2. And then we got sine 2x is equal to -1/2. And then we got sine x minus pi 6 is equal to -1/2. Okay, so the first one's going to be pretty straightforward, I think. So remember, sine is a y value, what we're looking for. And if we look at this one, we have square root of 3/2, 1/2. So that has our y value that's 1/2, but we wanted a -1/2. And so we can mirror it right there. And then also mirror it right there. Okay, so it's the two green dots that we're looking at. And we just want to find the angle that makes those true. Okay, so this is going to be 2 pi minus pi 6, because this would be pi 6, this is also pi 6. So this one is 2 pi minus pi 6. Maybe I won't put it right there. So we want 2 pi minus pi 6. So if we multiply this by 6 over 6, we get 12 minus 1, so that's 11 pi 6. Okay? Now this one is going to be pi plus pi 6. So we do 6 over 6. 6 plus 1 is going to be 7 pi over 6. Okay? Now, we want to check our rotation though. So if we rotate one time, we go through those points twice. Then we rotate another half and we end right here. We don't quite get to that point again, and so there really is just the two answers. Okay. Now, we have sine of 2x, and so it's a little tricky because we need to start by modifying this. And so if we want this to be a 2x, we're going to multiply everything by 2, and that will give us like the range that we're looking at. So we're going to change it to 2x and 6 pi. Okay. Now, so for a little bit, we're kind of treating this like it's just x, but it's tricky. I'll just have to kind of show you how we do this. So now we're going to rotate 3 full rotations, because we're going to go 2 pi, 4 pi, 6 pi. Okay. Now we're going to 1/2 again, right? And we've already done the math for that. So we know that this is 11 pi 6 from the previous problem. And we already know that this one is 7 pi 6. Okay. And so if we do one rotation, we get, let's see, I'm actually going to give myself more room. Okay. So the first one we get to, I'm going to start writing it over here. So I'm going to say 2x, because remember that's what we're really looking at, is equal to 7 pi 6 and 11 pi 6. Now if we rotate again, we're going to add 2 pi to that, because we go one time around, so that's 2 pi plus pi 7/6. So we have 2 pi plus 7 pi 6. Now, I'm going to think of that like 12 over 6. So essentially, I just need to add 12 to this. And so I get 19 pi 6. And then I'm going to add 12 to this one because it would be the same thing that I'm adding to add to this one. And so that's 23 pi 6. Okay, and then we have to go one more rotation. So these last two, I'm going to add 12 again. And so if I add 12 to this one, I get 31 pi 6. And then I get 35 pi 6 if I add 12 to this one. Okay, so those are all our values for 2x. But now we want to divide everything by 2 because we want to know just for x. And so essentially dividing by 2 is just multiplying all of the fractions on the bottom by 2. And so I'm just going to rewrite everything with a 12 on the bottom instead of a 6. And those are all our possible values. All right, that was tricky. Okay, now we're going to use similar logic on this last one. We need to change what we're looking at like we did before. And so we're going to kind of treat this like it's x. And so we just write x minus pi 6 in the middle. We have less than or equal to's on both sides. And so if we did, so on the original it's 0. So if we do 0 minus pi 6, we get negative pi 6. And then if we do 3 pi minus pi 6, what is that? 3 pi minus pi 6. So we want to times this by 6 over 6. So it's 18 minus 1, so that's 17 pi 6. Okay. Now we go through the unit circle, and it's a little tricky, but we have our same places because it's still negative 1/2. So we don't have to figure that out again. 7 pi 6. Okay. Now, this part is probably the trickiest conceptually. So we're starting at negative pi 6. That means we rotate this direction pi 6. So we're actually going to start with this 11 pi 6 marker. But since we went backwards, we're just going to call it negative pi 6. And this is equal to x minus pi 6. Okay? All right. Then we rotate and we get to 7 pi 6. And then we rotate a little bit more and we get to 11 pi 6. Okay? Then we go another one. And this is where we're basically going to follow what we did over here, written in white. So we get to 19 pi 6, 23 pi 6. So let's just recap. So we rotated back and we got our negative pi 6. Then we do one full rotation, and that covers this one and this one, which we got right here. Then we do a second rotation, and we end up with this and this. And now we're going to do a third rotation, and we're going to end right here. And so we end with 31 and, wait, no we don't. Oh, yeah, we only go to 17 pi 6. So I take it back. We don't need these ones. Okay, so we only needed those three. So that's good. because our ending point is 17 pi 6, and this one was a 19 pi 6, so that's too high. Okay, now what we need to do from here is we need to add pi 6 to both sides. So essentially we need to add pi 6 to all of these values. So if I add pi 6 to negative pi 6, I get 0. If I add pi 6 to this, I get 8 pi 6. And if I add pi 6 to this, I get 12 pi 6. And then we just need to simplify those. So 0 is fine. And then we get 4 pi thirds. And then these just become 2 pi. And so this is what x equals. And that's it on that one. But there's lots. Let's see, we have 1, 2, 3, 3 more. I think I'm going to cut it into 2 videos. So I'm going to stop on this video and then do a part 2. So calculator.